give you all the details on this mission. So right now we're about T-minus 1 hour and 3 minutes. Liftoff is slated for 8:51 p.m. UTC. Oh, that's out of date. I'm sorry. It's actually 9:58 p.m. UTC, if I remember correctly. And this will be the first of 3 Mars departures this year. The other 2 are Tianwen-1 from China, which I believe is launching July 23rd, and Perseverance, which will be launching...
Hey, your music's loud. Cut the music.
What?
The music's super loud. Nobody can hear you. That's what I'm...
Sorry. Alright. And the other Mars departure is Perseverance, which will be launching July 30th, hopefully. Anyway, back to Hope. Hope will be launching from Launch Area Y1 at Tanegashima Space Center in Japan. That's like very southern Japan, and that's because launch pads tend to be close to the equator because you want to get all that speed. I don't know what else to say. This is the 53rd orbital attempt for this year, and this will be the 42nd flight of the H-IIA rocket. So now to give you more details about Hope and the H-IIA is at Stiffle. Take it away.
All right. Good morning, evening, good night. Welcome to Astra Society's stream of the Hope Mars mission. As Elsie said, I'm going to be lifting off here in just about an hour, I believe. So yeah, we should be getting our go-no-go poll here in the next couple of minutes. So once that happens, we will bring you that. If it's no-go, we'll deal with that. But if it's go, I think we transition to what's the next milestone after no-go or go-no-go.
I mean, feelings complete. I think it's...
Yeah. Fueling was completed, I believe, about 7 hours ago. Hydrogen is loaded on the vehicle. Liquid oxygen should... Is the music still too loud? Oh yeah. Yeah, just cut the music. Nobody can hear us.
The music is cut.
Nope. Music's not cut yet.
What? How is it not cut? Hold on. Sorry guys. I'll figure this out.
There we go. All right. Live coverage should be able to be heard now. Yeah. All right. So.
Yeah, I accidentally had it duplicated. So that's me.
All right. So let's go over everything. So, for those just joining, welcome to Astra Society's restream of the Hope Mars mission. It's going to be launching here in just about an hour from Tanegashima Space Center in Japan. It's going to be the 42nd launch of an H-IIA rocket. So that is a hydrogen-fueled rocket launching from Japan. It's a Japanese-built rocket. 2 solid boosters, and yeah, it's going to be awesome. So it's the Hope Mars mission for the UAE. It's going to be an orbiter without no lander. It's going to study the Martian atmosphere and other things around Mars. So it's going to be the first ever interplanetary mission for any country in Arabia. So super exciting here. yeah, so just kind of looking at chat. Anyone, if in chat, if you have any questions, let us know. Just ping me or LC123. I don't know if you've been in chat. Or you can just ping Astra Society. We'll get that down. So, yeah, so about the H-IIA, two-stage with strap-on boosters. Fairing separation happens during first stage flight, interestingly. So think of like Ariane 5. Hydrogen fuel burns for a long time. Crispy, how long does it take to get to Mars? I believe they have a 7-month coast.
Yeah, it's somewhere around 7 months.
Yeah, so somewhere around 7 to 8 months is the coast. Yeah. So this is, again, as we mentioned, the 42nd launch of an H-IIA rocket. First flew in August of 2001. So it's a very, very old rocket, heritage hardware. Cool. So it only had one failure ever, and it was in 2003, 2004. Very long time ago. Very reliable rocket. Yes. November 29th, 2003. So, yeah. Should be able to see a rocket launch today.
Yeah.
Do you have anything else you want to add?
I just noticed I didn't advance the next up graphic. That is my bad.
Oh, yes. So, Go No Goal poll should be happening here very, very soon. So we'll bring you word on that as soon as we get it. Yeah.
It would really suck if this gets scrubbed. Like every single launch, like recently. Has gotten
Yeah,
scrubbed a
we've kind of
lot.
been having a scrub fest recently, but
Also, just got a notification in 24 hours. SpaceX will launch their Anasis, whatever, that in on their Falcon 9 rocket, and we'll be doing a stream for that.
Oh, here we go. At Astra Society, will the orbiter do any aerobraking to capture into Mars orbit? I do not believe so. There is no heat shield on the spacecraft, as far as I'm aware. I believe it'll be a fully chemical burn to get into orbit, so there will likely not be any aerobraking unless something happens. Mars Climate Orbiter.
Yeah.
When will live coverage begin? I believe live coverage begins at T-minus...
It actually should have already begun.
Yeah, it should have
like,
begun.
now.
Yeah, so whenever that begins, we'll bring it to you.
There's actually... the official stream is already going, but it's the like Arabic stream, so I have no clue what they're saying, and most of you probably also have no clue what they're saying.
Do we get video?
Huh?
Do we get video?
Oh yeah, sure, I'll bring that up.
Oh yeah, let's try to get some video.
I'm trying to figure out why this isn't working. Hold on. Oh, never mind, I got it. Alright. Stand by. Just keep talking.
All right. So here, another question. Or not really a question, but statement. High failure rate to Mars. Yes, but that's actually landing. I believe it's a 40% success rate for landings on Mars. But this is going to be an orbiter mission, which is generally a lot easier since you don't have to deal with the atmosphere and the communication delay. So everything should be hard programmed in. And because the spacecraft is actually symmetrical, you won't have to do any of those correction burns like Mars Climate Orbiter did, and so that's actually how the Mars Climate Orbiter mission failed. So that shouldn't happen, and here we go. Yes, Go No Go poll has been completed. We are go for launch of the H-IIA rocket. So just getting this from the JAXA. A go command was issued for the final countdown. Work 60 minutes before the launch time. Green light has been given. So we are go for launch at the T-minus 54 minutes and 30 seconds mark. So we will get another final go no go poll at T-minus 15 minutes. And after that, be up to launch directors. So yes, we are go for launch. So I believe now that the Go No Go poll has been completed, we will get the official stream. We'll show off some rockets.
Okay, watch this
And
animation that's about to happen. It looks easy. It really isn't. Ready?
I'm waiting.
All right. That took too long to do.
Oh yeah, nice. Full screen. All right, so unfortunately, I believe they're speaking in Arabic. So we won't get any audio for now, but once we get the official stream, I believe there's going to be an English stream.
This is the English stream, and by the way, their stream is down.
So the UA go out and
Oh, no, there it
Yeah.
is.
Yeah.
It's back, and it is in English. Yeah.
Oh, it is?
Yeah. Do you want me to bring the audio up?
Yeah, you can bring it up.
Information is going to be coming out, and as mentioned, this information is not just arbitrary. This is really information being looked and sought out for in the space community today. I think the teams that were over in Japan, they've been there, as I mentioned, since April. I'm sure they miss their families, but these guys are heroes to us. They're group of 17, been there since April, haven't seen their families, haven't seen their kids, and they've just dedicated their whole time now to making sure the success is there. With the delays that have happened with weather, that's part of the natural launch campaign. All of these things, the engineers look through this, they anticipate these things. We have a window, calculations are pre-calculated on a daily basis, anticipating a disturbance due to the weather or a delay due to that. So from my side, being here at the studio, it's a little different. You don't have the air of the whole team around you, but I know at the UAE Space Agency,
delays that
we
have
have a team
happened,
over there. They have a gathering put together.
All launches have
and
been
I'm sure they're all celebrating right now as well.
And
and the whole team's over at the NBRSC are doing the same.
I mean, you mentioned the delay. I mean, for us, we were sort of ready to gearing up to go on air. We were very excited about it and gearing up again. We totally
Mars
understand
window
the situation means that you
super exciting. We should have two other Mars
have to have
missions.
that delay. I'm thinking the team over there slightly more cooler, a bit more ready, and actually maybe potentially expecting the delay to have taken place.
Yes, honestly, it was quite funny. It was probably around the 18th.
Yeah. Taiwan
it was actually just the weekend before that. I was asked to join the EMM media committee, so I was mostly working with the project director.
Also, I'm gonna put on the stream with no commentary while you're speaking.
Okay.
Communicate with him, make sure things are going fine, and reporting up, and so we were pretty much done and ready, and I was asked then to join the media team. And
all right, we should be good. Should be able to hear me now. All right, so sorry, bear with us. We're first live coverage. We're still working out all the kinks. So yeah. So yes, this is going to be the first mission to Mars of the 2020 Mars launch window. So the two other missions are going to be from China and the USA. China is launching their Taiwan 1 mission, which I believe is a lander. And USA is going to be launching the Perseverance rover. So I don't know if we have a launch date for Taiwan, but I know we have July 30th for Perseverance. So
I believe Tianwen is the 23rd, but that might be out of date.
It might be. It's hard to know for sure with China until it actually happens. So with Perseverance, we know it's targeted for July 30th. And we will hopefully be able to bring you guys live coverage of that as well. So just kind of future coverage for Astra Society. Tomorrow we are going to be covering the Anasis 2 mission. It's going to be launching on a Falcon 9 from Cape Canaveral. Yeah. So let's listen to the stream for a little bit. If you want to turn the audio up. Yeah.
اللي بيمر فيها المسبار على أكثر من 490 مليون كيلومتر لما يوصل إن شاء الله الكوكب الأحمر في فبراير 2021 بإذن الله تعالى، واللي تعتبر أيضا أحد أهم المراحل في المشروع اللي هو يسمونه المارس أوربت انسرشن، الدخول في مدار المريخ. 30 دقيقة هاي طويل العمر بتكون من أكثر المراحل الحساسة. بنقوم بإنزال سرعة المسبار من 121 ألف كيلومتر في الساعة إلى 18 ألف كيلومتر في الساعة.
مشكور على الجواب يا ولدي، مشكور، الله يحفظك وموفقين إن شاء الله. وهذه فرصة نحن نشوفكم ونفرح وياكم بهذه المناسبة، واللي شرفني فيها أخوي محمد الله يحفظه في دعوتي أني أكون موجود معاكم. موفقين.
يا مرحبا يا طويل العمر، لكن لولا قيادتكم لما صار هذا، وأنا أشكركم على هذه القيادة.
All right, sorry about that. This is supposed to be the no commentary stream, but unfortunately, as you can probably tell, there is a lot of commentary. It's in Arabic too, so unfortunately, there's not really much we can do about that. So we're just going to give you guys some commentary from us until the JAXA stream starts, and we will bring that to you guys as soon as possible. So if you're just joining us, JAXA is targeting 21:58 UCT on July 19th. That is in just about 47 minutes and 30 seconds from now for the 42nd mission for the H-IIA rocket carrying the Hope Mars mission for the United Arab Emirates. This is going to be a Mars orbiter. Excuse me. It's going to get to Mars in about 7 months. And yeah, it's going to be the first Mars launch for the 2020 Mars window. So about 15 minutes ago, the go, no go poll was completed and we are go for launch. We will have a second go, no go poll conducted at T-minus 15 minutes, but so far it's looking good. We have another tweet from MHI launch services. Weather conditions are perfect at the pad. We are go for the, is it a sunset launch? I believe so.
I don't know.
What time is it in Japan?
Yeah. So do we want to go over, did we go over the experiments on this thing yet?
We haven't. Would you like to do that?
Oh yeah, sure. So some people on the LC123 Discord were asking like, what is the payload? So it's the Hope Mars probe, which is built by the United Arab Emirates, and it's going to study the Martian atmosphere. So it has these 3 scientific instruments, the Emirates Exploration Ion Imager. So this is a multi-band camera that'll examine water, ice, dust, and aerosols, as well as the abundance of ozone in the atmosphere. Next up is the Emirates Mars Infrared Spectrometer, and this is going to examine ice, water vapor, and temperature profiles in the atmosphere. And finally, we have the Emirates Mars Ultraviolet Spectrometer, which is going to measure emissions and the variability of the thermosphere, hydrogen, and oxygen corona. So back to you.
All right. So another thing to mention that this probe wasn't built only by the United Arab Emirates. It was in a collaboration with the University of Colorado and Arizona State University. So yes, this is a international effort to get this probe to Mars, which is super exciting. Love to see that. So we're going to go on some kind of let's see. So yeah, I think what we can do now is we can take some questions from chat. Anybody have any questions? We can answer them for you guys.
So a lot of people are asking about our Discord. So we've actually mostly been using that for internal things, but if you guys want, do you want us to put an invite link in the chat?
Maybe. This Discord's almost for like internal things at the moment. Yeah. So
well, I mean, for now, if you want to just ask. Well, yeah.
Yeah. But we should hopefully have a public Discord up very soon.
Somewhere soon, yeah.
Somewhere soon, yes. So we'll get onto that.
Yeah.
All right. So we are coming up at T-minus 44 minutes. we are go for launch and of the Hope Mars probe. Let's see. So we should have the live coverage, the official stream coverage start soon.
I believe that actually starts at T-minus 15 minutes. The one from Mitsubishi.
Oh, is it T-minus?
This is the one provided by the UAE.
Okay.
I'm just
so we're
annoyed
just gonna
lied about no commentary, because there was commentary and then no commentary stream, but whatever.
I just wanted to bring up before we go any further is we're talking about a lot of historical firsts this evening. The first Arab interplanetary mission.
All right, so if you're just joining us, we have the Go No Go poll has been completed, and we are go for launch. We are at just about T-minus 42 minutes and 45 seconds from the launch of the Hope Mars mission. From the from Japan. The Hope probe was built by the United Arab Emirates in collaboration with the University of Colorado and Arizona State University.
And this was dedicated to the Arab world. And I think that's what made this, so much bigger.
So what does the launch decision mean? Okay, so we have a question from Time Wester Sebi in chat. What does launch decision mean? Isn't it usually go, no go poll? Yes. So that was completed just about 18 minutes ago. So checking up on rocket systems and the weather. And so currently we are go for launch. Everything is looking green. If anything were to happen, we will let you guys know. So if any one system looks out of place or something is wrong or the weather changes to red, we will definitely let you guys know about that. But as of right now, everything is looking green.
And I'll bring up stream audio on the commentary stream.
Okay.
They say that as they start
to go further and further, they start to point at, oh, that's my country and that's my country, and then it's, oh, that's my continent, that's my continent, and then it goes silent because people realize then, hey, we have one Earth, there are no borders, there are no lines, and that's what honestly I found is really fantastic when coming into this space. I mean, the previous industry that I was in was very secretive in the sense, and it was all very much aligned to country capabilities and all. And coming to the space side, it's been phenomenal because we pull together academia, we pull together students, professors, industry, scientists from all around the world, and that's just what's made all of this so phenomenal for me just in the last 5 months of being part of all of this.
Absolutely. There's a lot of messages that this mission sends its completion instead of 6, amongst other things that we'd like to get back to. But right now, we have a very interesting guest with us, ladies and gentlemen, and that guest, of course, is Emirati astronaut Sultan Al Niyadi, and the right man for the right occasion, joining us right now in a video call. A very good day and a good evening to you, Sultan, wherever you are right now, and thank you for joining us. And let's break it with the first question. Last year in Kazakhstan, it was a huge moment when Hazal Mansouri, your colleague, your brother, became the UAE's first astronaut and went to the International Space Station. Now, and we kind of know that at those last 10 seconds at launch, you were concerned for him. How are you feeling now towards a mission that is unmanned, but it carries the hopes and dreams of 7 Emirates and the entire Arab nation?
Well, first of all, good morning, and thank you for having me. So I think in terms of personal feelings, I think it's different. Last time it was a manned mission, so it was a human being on top of the rocket. Now we're talking about a satellite. In terms of the excitement, I think it's kind of similar. It's something new for the whole nation, for the whole region. and we are excited for it. And it will be quite an interesting journey because it will last for 7 months. So I think it's going to be a really exciting 7 months ahead.
Yeah, it's actually going to be a journey for us as well as the probe that gets sent back home to Earth. How important do you see this mission being for the UAE space program, but also for the Arab world as a whole?
Well, it's called Hope Probe. The name was an indication at the time when the Arab world was facing hardships and difficulties. So it's a strong message. Obviously, it's a big milestone for the UAE, and it's a matter of capabilities, developing the technology, and enabling engineers, scientists, and building a platform for this nation and the Arab region.
So part of reaching this historic moment has been the UAE's young people. How can that add up to the UAE's youth, and how can they enrich this program and this mission in the future?
As you may know, that the average age of the engineers in the MBRC are 27 or is 27, and to have these projects inspiring them and build some sort of enthusiasm to look beyond normal. So I think in the future we'll have more exciting projects. Yes, we have the capability to build satellites, and through a good partnership we did send an astronaut, and hopefully this will be sustainable. And now we're sending probes. So in the future we will definitely be more exciting, like sending landers to Mars again, or maybe very exciting ahead of us.
Well, we seem to have a little bit of interference on the line, but we want to keep talking to you, Sultan, because it's so fascinating. You're one of the only people who's actually been through the UAE space program, through training for it. What is it about space exploration that excites you so much?
Well, I don't want to sound cliche by saying it's like a dream since childhood. It is. But in terms of the current science that we could be involved in, it's very exciting to help humanity explore space. It's very exciting to be among the elite.
Yes, put that one on. Elsie, are you there? Whatever live stream that Lucas just put in, please put on that one. It actually has the rocket on it.
Sultan, the Emirati astronaut, thank you very much for joining us at this moment of this historical day.
Yeah, we would love to have chatted to you for a little bit longer, just fighting against a bad line there, so sorry about that. Now, anyone who's been following...
I'm just going to play some KSP while I wait.
Now, fortunately, we have more than one opportunity to get the Hope probe into space. Here's more information about that launch window.
Why is RSSRO so hard? I can't get to the moon. It's so hard.
That's easy.
Bro, like, I try to use MechJeb, I don't touch it. MechJeb is so difficult.
Yeah, MechJeb is dumb.
I think I might... Is Kerbal Alarm Clock compatible with 1.18? 1.81?
I try to use MechJeb, I don't touch it.
What?
Are we live?
No.
Okay. We're live. Crispy, we're live. Mute yourself. All right. I think we're live now. Sorry about that, guys. Yes, we're live. Hello, we're back. Sorry about that, everybody. Somebody didn't tell us that we were going back live. So it is currently about 7 in the morning, I believe, in Japan. So there's going to be a morning launch at about 7:55 local time.
Sorry, I realized I was trying to warn you were live, but then I realized like something was up with my mic.
Yeah, you were kind of muted.
Yeah. Well, sorry.
Yeah.
I was gonna. I'm not sure if the stream heard this, but I was like, we are imitating NASA with the hot mics stream.
Were we?
It was a joke. We're like T-minus 32. Next miles. Final go no. Go no go pull at T-minus 15.
You might want to turn your audio up a little bit. Just turn up Discord in general. All right. All right, for everybody just joining us, we are currently T-minus 32 minutes from the liftoff of the Hope Mars mission from Tanegashima Space Center in Japan. This will be the 42nd launch of the H-IIA rocket. And this will be the first interplanetary mission for the United Arab Emirates. Super exciting. All right, so we will get the official stream from JAXA in 13 minutes. So we will switch to that whenever that starts.
So that stream is actually by Mitsubishi Heavy Industries. I think that's one of the things. The H-IIA rocket is actually not built by JAXA, it's built by Mitsubishi. There might be like related in.
Yo, yeah. JAXA controls everything. All right, but as you can see on your screen, we have a live view of the launch. There appear to be sprinklers on the launch pad. I'm not exactly sure what that's about. I'm not super familiar with Japanese launchers.
Yeah, me neither. And right now we're at T-minus 30 minutes.
All right, so let's talk about the H-IIA rocket, because I've seen a couple where, yeah. So it has a capacity of about 15 tons to low Earth orbit, which makes it pretty much comparable to about the Atlas V. So this is the 42nd launch of the vehicle. It has had 40 successes before this and only one failure, making it one of the most reliable rockets that are currently flying. So its associated rockets are, of course, the H-2 and the H-2B. The H-2B was, I believe, retired very recently. And so the H-IIA will be flying until the H-3 comes online in, I believe, 2022. So the first stage has one LE-7A engine. It's a Hydrolox engine, has a specific impulse of about 440 seconds, which is very good. For those of you who aren't super familiar with what that is, specific impulse is basically your rocket's efficiency. So it is a very efficient engine, burning liquid hydrogen and liquid oxygen, and it burns for about 400 seconds before MECO and stage separation. The second stage has one LE5B engine, produces just about 1/10 of the thrust, but it also has a specific impulse of about 450 seconds. So this is the second stage is what's going to put the probe into orbit and will inject it into Mars transfer. Additionally, there are also 2 solid rocket boosters. Each produce just about double the thrust of the main engine, and they burn for just about 120 seconds before they will be jettisoned. Elsie, do you have anything you want to add?
Oasis, during terminating Oasis?
No, they just mentioned range is green though. So.
Oh, good. Okay. Range is green. Everything is go for launch. So the final official go no go poll will be conducted in just about 13 minutes from now, at T-minus 15 minutes. So if that is green, they will proceed with terminal count. So let's go. We can go over some launch events that are going to happen. So starting at T-minus 4 minutes and 30 seconds, the launch auto sequence starts, where the rocket itself will start to control the count, and the rocket will call the hold if anything is needed. So 10 seconds after that, at 4 minutes and 20 seconds to launch, the tanks will be pressurized to flight pressures. At 3 minutes, the vehicle and payload will switch to internal power. And at 1 minute and 13 seconds prior to liftoff, the water deluge system will be activated. At T-minus 5 minutes before liftoff, the first stage engine will ignite. At T-minus 1 second, the boosters will ignite. And at T-minus 0 seconds, the hold down clamps will be released and the rocket will lift off. At T-minus 1 minute and 46 seconds, so that's about 20 seconds after booster flame out, the boosters will be jettisoned. And at T plus 4 minutes and 6 seconds, the fairing will separate, exposing the probe for the first time to the vacuum of space. At T-minus 6 minutes and 34 seconds, we will have MECO, or main engine cutoff of the first stage engine. After that, the first and second stages will separate, exposing the engine to space and allowing it to clear the first stage and ignite. So there are 2 planned burns for the second stage. First will be orbital injection, and then there will be a coast phase of about 30 minutes. So at T plus 11 minutes and 21 seconds, the second stage engine will shut down, and it will coast until T plus 56 minutes, where it will ignite again for about 4 minutes to add the velocity needed to get the HOPE probe to Mars. And just 1 minute after second stage cutoff, the HOPE probe will be deployed. And that will conclude our webcast. So T-minus 25 minutes and 9 seconds to liftoff.
Look at that mission control, man. That looks so cool.
Yeah, I believe that's mission control in the UAE. They are monitoring the HOPE probe in collaboration with Mitsubishi Heavy Industries, who is operating the vehicle today.
And again, if you have any questions about the rocket, mission, the probe, whatever it's going to do, just let us know in the YouTube chat.
Yes, we are more than welcome to take questions. Elsie, would you like to give another rundown of the experiments that are on the probe?
I mean, they've heard me say it. Does anyone else want to do it? If not, I can do it. I guess I'll just. So you heard this earlier, but I'll go over it again. Just joined. So this thing, it's a probe. There's no lander. It's not going to land, but that's okay because it has a bunch of experiments on it. So this is, again, it's built by the United Arab Emirates, and it has 3 scientific instruments that are going to go help explore the Martian atmosphere. So the first one is an ion imager. It's a camera that is going to examine. It's a multi-band to be specific. That's going to examine water, ice, dust, and aerosols, as well as the abundance of ozone in the Martian atmosphere. Secondly, we have the Emirates Mars Infrared Spectrometer, which is going to examine ice, water vapor, and temperature profiles. And finally, we have the Emirates Mars Ultraviolet Spectrometer, which is going to measure emissions and variability of the thermosphere, hydrogen, oxygen. So that's that. Does anyone have to add?
Yes, we just got some information. We're going to tell you guys about the control system on the Hope probe. So propulsion is provided by 4 to 6 120 Newton thrusters. So I believe that is about 20 pounds of thrust mounted on the bottom of the spacecraft using a monopropellant hydrazine fuel. Attitude control is provided by 812.5 Newton reaction control system. So that is about 4 pounds. So these are very light thrusters, which will be used to control the spacecraft when it is in coast phase to Mars, and once it has, and they will be used to inject itself to Mars orbit. All right, so if you're just joining us, this is the launch of the Hope Mars probe. This is going to Mars, launching in just about T-minus 2139.
And we're nearing T-minus 20 minutes, and hopefully the Mitsubishi stream will start.
So what is the weight of the probe? Launch mass is about 1,350 kilograms, so just above 1.25 metric tons. So it's pretty light as far as satellites go, but it's about average for what you'd expect for interplanetary probes. So yes, this probe is a little bit heavier than the Curiosity rover itself.
Do we want to talk a bit about that's somewhat related?
The rover?
Well, that's the other Mars project. Well, actually, maybe not. We'll save that for the actual.
Yeah. All right, so we're about 5 minutes until the official webcast starts, and about 5 minutes until that primary go no go poll and launch decision is conducted. So Scott in chat asks how long for it to reach Mars. It is planned to inject itself into Mars orbit in February of 2021, so just about 8 months away from now. So it'll take it about 8 months for it to get to Mars. And again, if you have any questions, feel free to leave them in chat. We will answer those for you. All right, so we've got a bunch of new viewers, so let's go over this. This is the Hope Mars mission destined for the Red Planet. This is going to be the first interplanetary mission for the United Arab Emirates, being launched from Japan on an H-IIA rocket. This is going to be the 42nd launch of the H-IIA rocket, which is one of Japan's workhorse vehicles. In just about 2 minutes and 40 seconds, we will have the official webcast starting, and the launch decision will be conducted. Yeah. So this probe will carry 3 scientific instruments who will study the red planet for the atmosphere. Yeah, to study the Martian atmosphere.
And another quick note: the countdown timer you guys see on the top right might be off by like 10 seconds. I'll try adjusting it as we get closer, but that's just because of the inherent latency streaming live.
A little fun fact about the Mars probe. A couple American universities also participated in the development of this probe.
Yes, so there were 2 American universities that collaborated in the production of this probe. So it is going to be the University of Colorado and the University of Arizona State. No. Yes, that's great. Just coming up on T-minus 17 minutes and 30 seconds.
So Mitsubishi have started their stream, but it's just showing a slate right now. So if they show something more interesting, we'll bring that up. But until then, we'll keep what we have right now.
All right, yeah, so just keep an eye on that. Because of extremely different volumes, unfortunately. Okay. So we're going to take a quick break, and we'll be back in just about 2 minutes.
All right, should be back, and we have just passed T-minus 15 minutes.
All right, so yeah, we're back. T-minus 14 minutes and 36 seconds in the countdown. We're back. Our audio should be fixed. We should all just be about the same now. So yeah, we're sorry about that. Again, this is our first ever live coverage. We're still working out the kinks, and yeah. So launch decision should be conducted here very shortly. We will update you as soon as we get information on that.
So we have about 20 people watching, which is awesome. All right, we just received confirmation. We are go for launch. That was the result of the go poll that just happened.
So yes,
So,
go no go has been started, and we are go for launch. I do believe that launch has been delayed 5 minutes. It looks like.
Wait, has it actually?
Oh no, let's see how long ago this was.
Oh, it's a 7-minute old tweet.
Oh, it's 7 minutes old. Okay. So yeah, our launch timer is actually correct.
Huh.
Something like that. Yeah. Okay.
That's great.
So yes, we're about T-minus 12 minutes and 48 seconds to liftoff of the H-IIA rocket carrying the Hope Mars mission. So the next event will be launch auto sequence start, which is the rocket will take control of the countdown as we move closer and closer to liftoff. So the rocket, from this time, the rocket will be able to call a hold if it determines that any of its systems are out of order.
All stations in the M1.
Again, if anybody has questions, feel free to leave those in chat, and we will get back to you on
10-minute
those.
fall as go. EMM as go.
So you probably just heard on the stream, they just confirmed go for launch again, which is great.
قائد المهمة إلى جميع المطار جاهز للإطلاق.
So yeah, we're getting closer and closer to launch. Again, if you have any more questions, let us know in the chat.
T-minus 10 minutes.
So we're T-minus 9 minutes and 53 seconds into the countdown, or to liftoff of the H-IIA rocket carrying the Hope probe to Mars. So coming up at T-minus 4 minutes and 30 seconds, the rocket will transition to the auto sequence, which is when the rocket itself will take control of the countdown and will call holds or delays if it needs to. But right now we're looking good. Just about 6 minutes ago, we got go for launch from mission control.
Yeah. The Mitsubishi stream is showing a map of where this is going. It's going to be launched in the southeast direction from the. I can't really tell. Yeah.
So if you're just joining us, you're looking at a live view of Tanegashima Space Center in Japan with the H-IIA rocket on the pad, awaiting its liftoff in just about T-minus 8 minutes and 40 seconds, carrying the Hope Mars probe for the UAE.
And again, that is such an awesome mission control center.
Yeah, I know. Look at the design of that. It's awesome.
Rocket Lab is better. Changed my mind.
They do have gaming headsets at Rocket Lab.
And the lighting at Rocket Labs.
Rocket Lab also have gaming.
The lighting in Rocket Labs mission control is amazing.
It is pretty cool. So we're just about 3 minutes and 30 seconds till the rocket will transition to auto sequence start. So we're coming up on T-minus 7 minutes for the launch of the H-IIA rocket carrying the Hope Mars probe. So let's go over some of the science experiments that are going to be on this probe. So some of the key objectives for this probe are to study the atmosphere of Mars. So it's to understand the climate dynamics and global weather map of Mars. It's also going to explain how different particles in the Martian atmosphere interact, such as hydrogen, carbon dioxide, oxygen, and ozone. It's also going to understand the structural and variability of hydrogen and oxygen in the upper atmosphere of Mars, which can be crucial for studying the atmosphere. So we're getting awesome live shots of the rocket right now as fueling is currently underway for the liquid oxygen. So the H-IIA rocket uses two types of fuels. It uses liquid hydrogen and it also uses liquid oxygen. So liquid hydrogen fueling was conducted just about 8 hours ago. And liquid oxygen boils off, so it has to be loaded very close to the launch. And that has been underway for the past few minutes. So before anybody asks, yes, everything is okay. That is not smoke that is coming off the rocket. That is actually liquid oxygen being released into the air. So there is liquid oxygen that doesn't need to go into the launcher, and it is just vented out into the atmosphere. And it's super cold, and so it's a liquid, and once it comes in contact with the air, it instantly turns into a gas, which is why you see that white cloud coming.
T-minus 5 minutes, 30 seconds from auto launch sequence start.
By the way, I transitioned to the Mitsubishi because they started showing.
Yep. At T-minus 4 minutes and 35 seconds. Right
auto launch
now,
sequence
the
start.
rocket will be transitioning into auto sequence start. Rocket is in auto sequence. Next milestone right now is the fuel tanks have been pressurized to flight levels. In T-minus 1 minute, the vehicle and payload will switch to internal battery power. Oh, make sure you update the next up. Yes, with Mitsubishi, you can go anywhere, even space.
Yes. And apologies for forgetting to update the next thing in the bottom right, but I'll be doing that from.
Is my audio better?
Alrighty, if you're just joining us, you were looking at a live view of Japan's H-IIA rocket carrying the Hope Mars probe for the United Arab Emirates. This is going to be the first interplanetary mission for Arabia, and it is also going to be the first mission of the Mars Launch Window 2020.
Audio check. Am I good?
So this rocket is the H-IIA rocket built by Mitsubishi Heavy Industries in Japan. It is a two-stage launch vehicle with 2 solid rocket boosters, producing just about 5 meganewtons of thrust at liftoff. Coming up in about T-minus 1 minute and 30 seconds, the water deluge system will start, which will cushion the launch pad during liftoff.
Audio check.
I think you're good.
All right. Okay.
So the vehicle and the probe have transitioned to internal battery power, meaning they are no longer receiving an electrical connection to the launch pad.
T-minus 2 minutes.
We are currently T-minus 1 minute and 30 seconds to the launch of the H-IIA rocket. In about T-minus 10 seconds, the water deluge system will be activated, which will cushion the launch pad prior to launch. Or not prior, but during launch.
Pressurization of the liquid oxygen and hydrogen system of the second stage are complete. We are igniting the torch to power the excess hydrogen. Fueling initiates at the flame deflector of the launch deck.
By the way, I updated the launch timer, so that should be accurate.
Yep.
It's 1 minute to launch.
T-minus 40 seconds. At T-minus 5 minute or seconds.
T-minus 30 seconds.
Of the H-IIA rocket will ignite. And at T-minus 1 second, the 2 white boosters on the side will ignite. And at T-minus 0 seconds, the booster will lift off, carrying the satellite to space.
T-minus 15 seconds.
Water deluge system is active.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And I think our countdown's messed up.
No engine ignition. I think their countdown is messed up.
I think our countdown is messed up. Oh, wait, engine ignition? The sparklers are on.
So our countdown is a little
Engine
off.
ignition. Full thrust engine boost. Liftoff.
We have liftoff.
Yay. Sorry for the countdown. But as you can see, liftoff is
Roll program and pitch over maneuver.
T plus 20 seconds into flight, everything looking good for the launch of the H-IIA rocket. We should have max Q coming up right just about now. It looks like the vehicle is supersonic.
The H-IIA is now flying above Pacific Ocean to the east.
T plus 1 minute into flight.
The H-IIA flight is on course, and the Tanashima station is tracking the launch vehicle very well.
$20 seconds to booster separation.
燃焼終了. The SLBs have
we have booster flame out just about now.
Booster separation confirmed.
SLBA separation.
As you can see, the booster separation.
'So for the next about 1 minute and 40 seconds, we will have powered flight of the first stage, burning liquid hydrogen and liquid oxygen. After that, we have stage separation and ignition of the second stage engine.
And unfortunately, we don't have video on board the vehicle.
制御系飛行経路も正常です。ロケットは順調に飛行を続けており、現在の高度は約 95km、秒速約 1.5km。
T plus 3 minutes into flight.
The combustion in the first stage engine, altitude control, and trajectory are all nominal. The H-IIA flight is on course. Current altitude is about 95 km. Rest is approximately 1.5 km per sec.
T plus 3 minutes and 30 seconds, everything looking good on the booster. Unfortunately, we won't have any onboard cameras, but we should be transitioning to an animation here shortly.
Current velocity is 2 kilometers per second. Downrange 131 kilometers, I believe. Or is it altitude? One of the two. T plus 4 minutes into flight, 6 seconds from fairing step.
I can say basic rocket lab do have generally better webcasts. Other organizations. And there's fairing.
The payload
fairing separation confirmed. Velocity is 2,500 meters per second. I'm just gonna comment, how long does this core stage burn? T plus 5 minutes. Current velocity is 3,000 meters per second. What I presume to be the altitude is currently 171 kilometers.
Altitude control and trajectory are all nominal. The H-IIA flight is on course. The current altitude is about 170 km. Rest is approximately 3 km per sec.
We have call out trajectory is nominal.
Nominable.
Main engine cutoff coming under a minute.
T plus 6 minutes, current velocity 42,000 meters, 4,200 meters per second, 34 seconds to main engine cutoff.
42,000 meters per second.
T plus 30 minutes, current velocity.
Ow!
Sorry about that.
4 seconds to main engine cutoff.
Coming up on.
How long does second stage burn for? Second
main engine cutoff
burns
confirmed.
For
current velocity
530
5,200 meters per second. Altitude 213 kilometers.
Separation of the first and second stages.
Stage SEP.
第2段エンジン第1回燃焼開始。
Second stage ignition confirmed. Current velocity 5,200 meters per second.
everything looking good on the payload and on the booster.
T plus 8 minutes into flight. Current velocity is 5,600 meters per second, and altitude is 238 kilometers. T plus 9 minutes into flight. Current velocity is 6,000 meters per second.
制御系飛行経路も正常であり、ロケットは現在安定した飛行を続けております。現在の高度は約 250km、秒速約 6.3km です。
The combustion on the second stage engine, attitude control, and trajectory are all nominal. The H-IIA flight is on course. Current altitude is about 250 kilometers. Velocity is approximately 6.3 kilometers per second.
So you can see what direction it's pointing in, which I think is super cool.
So there will only be 2 second stage burns. So there'll be this burn that's happening right now to get into orbital injection, and then there will be another burn which will send it off to Mars.
T plus 10 minutes into flight. Current velocity is 6,500 meters per second.
ロケットは順調に飛行しております。ロケットは種子島内之浦の各地上局からの補足範囲を離れ、小笠原局から追尾されています。
Second engine cut off one, and as a reminder, there's
The
going to be a second
H-IIA is
burn.
in good shape. The launch vehicle has flown beyond the range of the JAXA Tanegashima and Uchinara stations and into the Ogasawara station.
Second burn will start at T plus 52 minutes and 3 seconds, so we're going to have a long coast phase.
T plus 11 minutes into flight, 7,100 meters per second. We are about
20 minutes to cut off.
15 seconds to cut off.
第2段エンジン燃焼停止。
The second stage engine cut off.
Engine cut off. Confirmed.
Current velocity is 7,300 meters per second.
So now
Altitude
we're in a bit of a
254
close
kilometers.
Until T plus 52 minutes and 3 seconds.
ロケットはこのまま完成飛行を続け、
So this is
間もな
interesting.
く
They're
小
not
笠原
actually
拠
in
点の速
orbit.
範囲
They're
を離れます
suborbital right now.
I think they're in orbit right now.
The
Mm-mm.
launch
They
will
are.
be short to
No,
Yeah,
that's not.
the trajectory line, it goes behind the horizon, so they're in orbit.
56分後に
Well,
they're
UAE
going
衛星探査機
Orbital
の運用を
velocity
予定
is
しています。
7,700.
次のイベントまで一
Is it?
旦実況放送を中断いたします。
Well, they're currently suborbital right now.
That's odd. Wait, how? No, impossible.
I mean,
Impossible.
There will be an intermission.
And insertion at the same
総
time.
合司令塔からの実況放送は午前7時43分頃に再開を予定しております。
This live coverage will resume at 7:43 a.m. Japan Standard Time.
ここで UAE が目指す火星探査計画についての映像をご覧ください。
The Emirates Mars mission is an inspiring project for us. We use this project to inspire our young people, especially people in the region. Through this project, we learned a lot. We gained confidence. We engaged with the international space community, especially in space. Will be shared with more than 200 institutions and universities across the world. This is UAE gift to the world. We are proud to work closely with our strategic partners, especially here in Japan, JAXA, H-IIA. We will celebrate together the successful launch of our Hope probe to Mars. Thank you.
The Emirates Mars mission had a lot of challenges since the day it was announced till today. There are technical challenges, but there are also certain administrative challenges. When you look at the time frame that was set for the mission, it was very, very challenging. 6 years compared to other nations that have 10 to 12 years to deliver such missions. The other challenge that we had was the launch. We have to launch in summer 2020 if we want to reach Mars before the 2nd of December 2021. Any mistake, any delay in the launch, we'll have to wait for 2 years. The other challenge that we have also is the cruise phase, in which we transfer the spacecraft from Earth to Mars in a 7-month journey. Any mistake happens during that phase, we lose our mission. And then when we reach Mars, there's another challenge. It's the Mars orbit insertion, in which we have to slow down the spacecraft from 121,000 kilometers per hour down to 18,000 kilometers per hour. We go too slow, we crash on Mars. We go too fast, we skip Mars, and we lose our mission. Once we succeed in reaching Mars's orbit, we'll have to transfer from capture orbit to the science orbit. That by itself is a challenge. And then we'll have to collect data, analyze the data, and come up with new findings about Mars, and announce it by the 2nd of December 2021. The Emirates Mars mission is the message of hope to the Arab youth. If a young nation like the UAE is able to reach Mars in less than 50 years, then we can do much more as a region. The same way we used to generate knowledge in the past, we can generate knowledge today and in the future to serve humanity.
この後は三菱重工業製作の映像をご覧ください。
All right, everybody, we're going to take a quick break during this coast phase. We will be back at T plus 45 minutes, so just in about 27 minutes.
In the infinite beauty of the universe, satellites, space probes, the International Space Station. Even at this moment, various spacecraft are contributing to our daily lives, and they are able to do so only with the forceful guidance provided by rockets. The body of a rocket is made of very thin sheets, only 17 millimeters thick. To reach outer space, the body must be light yet sturdy. The sheets are cut into a special shape called an isogrid structure, approximately 2 millimeters thick. This makes the body lighter and stronger at the same time. Next, the sheets are combined to form a cylinder. This becomes the rocket's fuel tank. Rockets, shaped like a long and narrow pencil, are mainly composed of fuel tanks. The fuel tanks are used for two kinds of fuel, liquid hydrogen and liquid oxygen, each contained in separate tanks. In order to reach higher speeds, the rocket is designed with two engine stages, each having two separate tanks. Next is the heart of the rocket, the engine. rocket engine combines hydrogen and oxygen together in the combustion chamber and blows high-pressure gas at a rate faster than the speed of sound. The heat from combustion rises up to 3,500 degrees Celsius, which requires the engine to be able to withstand extreme temperature.
Few technologies have impacted manufacturing as rapidly and broadly as 3D printing. Since its debut in the early 1980s, the global market for 3D printing has grown exponentially. Also known today as additive manufacturing, 3D printing can work with a broad range of materials. And 3D printers can produce just about anything you can imagine, from a guitar to a human heart, to even parts for a rocket. Japan is applying this amazing technology to producing parts for the H-3 rocket, the country's next-generation launch vehicle. In order to achieve increased payload capacity and shorter lead times to launch, the H-3 actually has fewer components than its predecessor, the H-IIA. The development and application of 3D printing technology at the manufacturing facility of Mitsubishi Heavy Industries, or MHI, helped make this possible. In the manufacturing process, powdered metal alloy is spread onto the printer's platform and is fused by a laser. The process repeats until the part is completed. 3D printing is more flexible than traditional processing methods. It supports creativity and is ideal for originally crafted precision parts. And 3D printers are space and cost efficient and can significantly help reduce material waste compared to other manufacturing techniques like cutting and grinding. Now, MHI Group has applied its advanced capabilities to the development of its own 3D printing technology. Lambda, developed by MHI Machine Tool, is a direct energy deposition additive manufacturing system that features two world firsts: a monitoring feedback function enabling real-time control, and a local shield function to allow the use of a wider range of materials. The same technology will allow Lambda to work on precision parts that are not only made of unique materials, but are also much larger than what other printers are capable of handling, often required by the aerospace sector. 3D printing's rapid transition from curiosity to powerhouse technology has revolutionized manufacturing and made the future more exciting than ever before.
After assembly, the rocket is transported to the launch site in Tanegashima, located in southern Japan.
Partnerships are key to the fourth industrial revolution. Companies are collaborating to develop the advanced technologies and solutions society needs. These innovations generate new streams of profit and make a sustainable impact on local communities around the world. They bring dreams to life. Brescia, a town with 3,200 years of history, is located in Italy's industrial center. Here, local steelmaker Ori Martin partnered with energy technology company Turboden to install a plant that recycles the steel mill's waste heat into electricity. The process also cuts the mill's CO2 emissions and benefits the bottom line, a dream combination that many energy-intensive industries can apply.
We invested a lot in the last year, especially to reduce noise, to reduce pollution, to reduce emission, and one of the most important projects we had is a recovery project.
Turboden's organic Rankine cycle technology, which generates the electricity, is at the heart of the project.
Most of the projects that we implement are based on a strong relation between our company, the customer, and other technological providers that complement our solution. And the Ori Martin project is a clear example of this.
Thanks to this plan, we can recover the hot fumes from the electrical arc furnace and convert them into energy. We can produce electrical energy compared to the consumption of 700 families.
Half a world away is a family-owned business in the American heartland. Steer Enterprises is a long-time part supplier to global automakers. The dreams and hard work on which the founder built the business 3 generations ago live on in quality partnerships today. The company chose Mitsubishi Caterpillar Forklift America to provide a fleet of forklifts to optimize its operations.
We always say that we're building our company for generations to come, so our decision making, whether it be purchasing a forklift, purchasing a business line, all of those are thinking 10, 20, 30 years out.
The long-term view is even more crucial in projects outside of the planet. Space has always been a dream destination for humankind, and Japan's new rocket aims to make it even more accessible. The Japan Aerospace Exploration Agency and Mitsubishi Heavy Industries are decades-long partners and are now working together on the H-3, Japan's next-generation rocket. Scheduled to debut in 2020, the H-3 will slash launch preparation lead time and price and build on Japan's world-class launch success rate.
まずこの H-3 ロケットの目的が
The objective of the H-3 is to lower the barriers to space development and utilization. It's very important to make space easier to access for humankind, and we need to make sure Japan always has a means to access space. By making the H-3 rocket less expensive than its predecessors, we aim to reduce the cost of going to space. This will spark robust space development and utilization.
That's a big dream, one that cannot be achieved alone. Engineering partnerships. This is what it takes to move the world forward.
Half a day before the launch, the rocket is transported by a special vehicle to the launch pad, entering final preparations for the countdown to liftoff.
Upgrade.
メインエンジン着火。3、2、1。リフトオフ。
Approximately 2 minutes after liftoff, solid rocket boosters are jettisoned. About 7 minutes after liftoff, the first stage rocket engine will be jettisoned. From that point, the second stage engine fires. The rocket, now lighter, accelerates its speed in zero-gravity space, ready to release the satellite to the designated orbit. The speed required to place a satellite into orbit is about 8 kilometers per second. At this point, the rocket would only need 1 minute to cover the same distance as a Japanese bullet train could in 3 hours. After the satellite is separated, the rocket's mission is completed. The rocket, taking over a year and a half to manufacture, finishes its short lifetime at 30 minutes after liftoff. Rockets are continually evolving. In anticipation of an ever-evolving state of rocket development, Mitsubishi Heavy Industries is developing its next-generation rocket. With decades worth of technologies and expertise, Mitsubishi Heavy Industries will continue to contribute to humanity through the utilization of space.
When it comes to society's biggest challenges, there are no easy solutions. That's why at MHI Group, we address big issues with the power of global integrated engineering and relentlessly pursue incremental advancement. To take on the growing demand for clean energy, we're pioneering alternative energy sources and cutting emissions from existing ones. We're anticipating the needs of rapidly growing cities through advancements in transportation and sustainability. Our innovations are revolutionizing how goods get to people around the world through digital warehouses and automation technology. We're making it possible for more people to experience the benefits of space technology with our next-gen launch vehicle. And we're building connections to more destinations with a regional jet that offers more space and comfort for passengers. The biggest challenges inspire our greatest innovations. And because we're constantly working to improve, our best never stays our best for long. So there are always even better things ahead.
では、ここでロケット搭載カメラの映像をお送りいたします。
And we are back, and it looks like right now videos taken on board of the rocket during. So that's the solid rocket booster jettison.
Beautiful booster sep.
That's the payload fairing, and that's the sun. So coming up in about 10 minutes, the stage engine starts again, which will put them into orbit on the Earth. And then shortly after that, the stage engine shuts off, we're going to...
まもなく RCC の実況が中継される模様です。RCC 実況にバトンタッチしますので、どうぞご覧ください。
Cool how we got onboard video this quick.
Shame they didn't put it live though.
Yeah.
Anyway, as it joined, we had a full lift off. We had a first stage burn, and then good initial stage burn, and now we're waiting for stage to start its second burn, but it and the Hope probe into orbit. Earth. Wait, Earth. Yeah.
All right, so we'll take a quick break here just again, and once this next live stream starts, we will bring that to you.
種子島宇宙センター竹崎総合司令塔から H-IIA ロケット42号機の打ち上げ実況放送を再開します。
This is a live coverage of H-IIA number 42 from the Toxic Range Control Center at the JAXA Tanishima Space Center.
UAE 火星探査機ホープを搭載した H-IIA ロケット42号機は2020年7月20日午前6時58分14秒に種子島宇宙センターから打ち上げられました。
Earlier at 6:58:14 a.m. Japan Standard Time today, from Tanashima Space Center, the H-IIA number 42 was launched with encapsulating the Emirates Mars mission Hope probe.
ロケットの追尾は再開されており、現在ロケットは完成飛行を続けています。
We have restarted tracking the launch vehicle. The launch vehicle is currently in a coastal state.
まもなく第2段エンジン第2回燃焼開始を予定しております。
We are shortly going through another ignition of the second stage engine.
Okay, not sure what happened earlier, but we are about 30 seconds from the second stage starting.
Are you sure?
Yeah, yeah. We just don't have any images right now.
I don't know if we're 30 seconds away. I think we might be like 4 minutes away.
No, we're like 3 seconds away.
Oh yeah, sorry, the Google Doc I sent you all is outdated.
Okay,
They changed the time.
Alright, so it's 3 minutes now.
I got you.
Second stage engine ignition for the second time.
So I switched over to the other stream, which apparently is showing mission control. So I think they confirmed that the second stage burn has started.
Yes, so we have confirmation second stage burn has begun. So this is going to be just about a 3.5 minute burn to inject the to inject the payload into orbit and to Mars. Currently about 2 minutes and 25 seconds from engine cutoff.
The Mitsubishi stream says the launch vehicle seems to continue the flight smoothly. Good. Obviously.
Yeah, it said that for a little bit, so.
Oh, sorry.
Currently about 1 minute and 25 seconds from engine cutoff. Be cool if we could get like some telemetry.
As we get near cutoff, I'm gonna put it back to the Mitsubishi, because even though they aren't showing views of anything, I believe they do have mission control audio.
Yeah. Sounds like they've transitioned back to like music and stuff. hopefully we'll get a
第2台のエンジン
confirmation here shortly
第
about
2回燃焼停止
what's happened.
Second stage engine cutoff.
All right, we have confirmed Seco, second engine stage cutoff, confirmed.
Yeah, so coming up in about 20 seconds, we have Hope probe, which will be separated from the second stage.
Hope 分離
The Hope separation.
And that's confirmation.
We have separation confirmed.
So launch is successful then. And everything is up to Hope. The H-IIA rocket finished its job. And now we'll transition to
Hope は予定された
عملية انفصال المسبار من صاروخ الإطلاق نجاح.
So it looks like in just about 3 minutes and 10 seconds from now, we will have the solar array deployed on the Hope spacecraft.
So now we're about 2 minutes. Solar panel deploy. According to the screens over there, it's happened at T plus 1 hour, 1 minute, or 19. And we're now just under 1 minute from solar panel.
And just about now, we should have deployment of the solar arrays on the Hope spacecraft.
Happening in about 3 seconds. Fortunately, the stream does not appear to have any audio. We won't have audio coming. And yeah, it does look like we have a successful deployment. Or sorry, deployment in progress. The solar panel.
All right, so this is going to conclude our live coverage for today's launch. Be sure to follow us on Twitter at Astra Society for more updates on when we will be doing more live launch coverages. Also, make sure you're subscribed, hit the bell, like, and y'all know what to do. And yeah, we should be back tomorrow at around 3:30 Eastern Time for the, no, 3:30 Central Time for the launch of Anasis 2 on a SpaceX Falcon 9. Until then,
And 4:40 Eastern. So.
Yeah, 4:40 Eastern Time. So until then, Godspeed and good night.